Hello everyone, welcome back, and today we're gonna start practice some applications of the simultaneous equation. Uh, so first thing first, we can start with the creating the simultaneous equation for us. For example, Mark by the 3 roses and 2 the guardians for $15.5. Peter by the 5 roses and 3 guardians for the $24.5. So we can say let R be the cost of the rows, and G be the cost of gardens. And then we could create something with and then what we do is and we could using that as to become our simultaneous equation. So 3R plus 2G equal to 15.5, and which is 3 roses and 2 guardians is equal to $15.5. 5 roses plus 3 guardians equal to 24.5. And how are we going to do this question? Let's go back to our simultaneous equation in here. And first thing first, we could, using algebra, self-system of equation, self-linear relation. And I'm going to change this one to R and G. Okay, perfect. And now what we do is with 3 multiplied by R, make sure you use the multiply, okay? Because otherwise they not recognize anything. So 2 multiplied by G equal to 15.5. Second one will be 5 multiplied by R plus 3 times G. So 3 times G equal to 24.5. Press enter. We can say R equal to 2.5 and G equal to 4. So it's not too bad actually. So now what we say is R equal to $2.5 per each and G equal to $4 per each. Yep, that's it. So you could you could substitution back this question and then check the answer, but normally you'll be fine. But I strongly recommend you guys to check. I'm going to show you how. So we say R equal to 2.5, G equal to 4. So we substitution maybe 5 multiplied by 2.5 plus 3 times 4. Is that going to be equal to 24.5? So let's try to figure out. So 12 plus the 12.5, so that equal to 24.5. That means we got the right answer. And then you could write again, so rows cost $2.5 each, and guardians cost $4 each. Perfect. That's it. That's the question, which looks like simultaneous equation. And another examples, which is we're using as a parameter with the rectangles. So we can say a rectangle parameter, and that's the rectangle perfect. 48 centimeters for the parameter. Okay, let W equal to weights, L equal to lengths. So we know the length for the rectangle is 3 times of the weights. Okay, so we can say length equal to 3w. That makes sense. Good. And then determine the dimensions. Okay, perfect. Now what we know is 2w plus 2l equal to 48, and l equal to 3w. That's our simultaneous equation. If you have that one, we could substitution the 2 into the one equation. So which means 2w plus 2 times 3w, which is L equal to 3w, equal to 48 centimeter. So 2w plus 6w, so 2w plus 6w equal to 48 centimeter. So 8w equal to 48 centimeter, though both sides are divided by 8. So w equal to 6 centimeter. And then we're using L equal to 3w equal to 3 times 6 equal to 18 centimeter. Then that's how you're gonna be checking. And then you can use the CAS calculator to calculate this question as well, but I just showing you how to use by hand, which is totally fine. You can use the CAS, please. And now we can use this as our another practice during the class. I want you guys to use the calculator. Okay, so make sure let something equal to something first, and then to make that happen. So this all basically for chapter 5, but we have one more left, which is 5J, piecewise linear linear graph. So we do that later as well. Hopefully that all makes sense, and I'll see you guys next time.